All right, today we're jumping into a design pattern with a name you won't forget, the zombie pattern. This comes straight from the engineering team at Wix, and it's their brilliant way of building systems that can survive failures, especially when you can't rely on old-school transactions. Let's dive in.
So everything starts with this one single non-negotiable rule at Wix. No transactions, not across different services, not even across different entities in the same database. Now, in a microservices world, this makes sense for scale, but wow, it forces you to think about data consistency in a completely different way.
And that right there is the million-dollar question, isn't it? If you've got an operation that needs to write to two different places, but you can't wrap them in a nice, safe transaction, what happens when the first part works, but the second one just fails? That's when things can get really messy.
And that mess has a name. It's called the orphaned entity problem. You can think of it like a ghost in the machine of your distributed system. It's this half-created piece of data just left hanging there after something went wrong. Let's make this super clear with an example. Imagine a user is updating their website. First, the system saves the new content for their pages. That works, great. But then, when it goes to save the updated site header, boom, the connection times out. That second write fails.
So what's the result? You've got these orphaned pages. They physically exist in the database, but nothing is pointing to them correctly. Even worse, the user might actually see this broken, incomplete state. For them, it's just confusing. For you, it's a data integrity nightmare. So how do you solve this? I mean, the textbook answer usually involves some kind of complicated rollback logic, but the philosophy at Wix is fundamentally different. They say, look, partial failures are gonna happen. So instead of trying to prevent them, why don't we just design our system to handle them from the start? And this slide just shows that contrast perfectly. On one side, you have the classic saga pattern, where you have to build this whole complex chain of undo operations. If step 2 fails, you trigger another action to undo step 1. It's a lot of work. The Wix way says, you know what? For failures that don't happen often, that complexity just isn't worth it. Instead, just accept the partial state, make sure it's harmless, and let a background process clean it up later.
This whole philosophy really boils down to a few key principles. First, your only guarantee is a single database write. That's your transaction. Anything else, like sending an email or calling another service, has to happen asynchronously, usually through something reliable like Kafka. But the big idea, the mindset shift you have to make, is that last one. You have to build your system assuming things will fail partway through.
And all of that brings us to their really elegant solution, the zombie pattern. I love the name, it's just perfect. It's an entity that exists in the database, but it's not really alive or visible to anyone yet.
So here's the official definition. The whole idea is you do your first write, but you stick a status on it, like pending or draft. This makes the new entity totally inert, totally harmless. It only gets activated, made real and functional after you've confirmed that all the other steps in the process have finished successfully. So what's the real difference here? Well, an orphan is a problem. It's visible, it's confusing, it's risky. A zombie, on the other hand, is completely safe. It's hidden away in a temporary state, and if the process fails and that zombie gets abandoned, no one ever even knew it was there. No harm, no foul. That's the beauty of designing for partial failure.
Okay, so the theory is cool, but how do you actually build one of these things? It's actually a lot more straightforward than you might think.
Let's just walk to it. Step 1, you create your entity, but you save it with that status pending flag. Step 2, you kick off all the other async stuff you need to do. Now, step 3 is the secret sauce. This is absolutely critical. Every single API in your system that reads this data must filter out anything that has that pending status. That's what keeps the zombie invisible. Then, step 4, once all those other jobs report back success, you just do one tiny update. You patch that status to active. And poof, the zombie is now alive. And finally, you can have a simple cleanup job that runs every now and then to just delete any old zombies that got abandoned.
Now you might be thinking, this adds a little bit of overhead, right? An extra field, a filter on all my queries. And you're right, you don't need to use this for every single write. The real skill is knowing when to make that trade-off between this extra resilience and just keeping things simple. This table lays out that choice perfectly. The ideal zombie pattern gives you that rock-solid resilience. But yeah, there's a shortcut. You could just skip the status field and hope for the best. And look, that shortcut might be okay if that second write almost never fails, or if an orphaned entity isn't a huge deal. But you have to know the risk you're taking. You could end up with those visible, confusing orphans that cause problems for your users.
And this really brings it all home.
Taking a shortcut is always a conscious trade-off. You're trading resilience for simplicity. For anything high volume or for flows that are absolutely critical to your business, you really should invest the time to do the full zombie pattern. That resilience is just not something you can afford to skip.
So, that's the zombie pattern. It's more than just a clever trick. It's a whole mindset shift. It's about designing your systems to expect and gracefully handle failure, instead of just pretending it won't happen. Which leaves us with a great question to think about. Where in your own systems could you start designing for partial failure, instead of just hoping it never happens?